All right, guys, we're going to take a look at 8.5. 8.5 is similar as far as there's only one homework assignment. So we'll have to just see how many parts there are on YouTube. It just helps to make them smaller videos. So we're going to be talking about something different here. I mean, that's all related, but we're not going to just have a brand new test. We're going to be talking about something called the Power Series. This 8.4, I gave you 2 days, so this is 8.5, so this is for April 16th. Okay. All right, so what does a Power Series look like? This is what a Power Series looks like. Let me give you even an example like this. All right, so let's say these can actually be different numbers. These technically can be different numbers. So it could be something like 7 plus 8x to the first plus 3x squared plus 5x to the third plus dot dot dot. Okay, and what is that? That is actually just a large polynomial. It's kind of like we say an infinite polynomial that keeps going on. So these power series are really neat because polynomials are always the easiest thing to work with. Okay, and this is the same thing. We just say that it's centered at A. It's centered at A. Here, this one is also centered, but where is it centered at, guys? This would be centered at 0, right? If there is no number, then this would be centered at 0. So this is kind of like a basic one, and then this is the general one. There could be any number there that we like. If it's 0, then it takes us down to the basic one. Okay. Let's see. So yep, I like to consider it a infinite polynomial. Okay, and this is kind of the cool thing about this. Every power series converges for some x value or x values. Okay, it could be as much as 1. It could be as many as all real numbers. Okay, but every power series converges. Yay! Okay, so we got something there to work with. All right, so let's talk about the 3 ways that a power series can converge. Here's my most general form, right? So only when x is a. There's literally one number when x is a, and basically there could be a few extra numbers at the beginning, but basically it takes you down to 0. It's kind of like a degenerate case, but technically we could say it converges. Usually when x equals a, it basically always converges to 0, but that is what it is. All right, it can do all real numbers. For any number you choose for x, it is going to converge, or on just an interval, okay? And it'll always be centered at a. And then let's say maybe it's 4 this way and 4 this way, okay? And we call that distance the radius. Okay. Let me make sure. Yeah, okay. I wanted to make sure they ask us for the radius on the homework. So we actually have to state the radius, and then we will also state the interval. Okay, so this distance, whatever the interval is, it's kind of neat. It'll always be centered around A. Okay, all right, so let's take a look. What are the directions? We did all that, we did all that. Maybe, should I back up? I'm thinking things in my head. Let's take a look at this. Were we okay with that example? These numbers, C is just going to be numbers. Okay, let's take a look one more time at this. C is just going to be numbers, constants, right? And they could definitely be different constants. And then do we see how, like when I plug in 0, the x goes away, and that's not it, why it's not there. Then I plug in a 1. Okay, then I plugged in a 2. Then I plugged in a 3. So you can kind of see the polynomial there. All right, just want to make sure you felt comfortable with that. Okay. All right. All right, so we are we're going to find the radius of convergence, okay, and the interval of convergence. Remember, these are automatically going to have, they're going to converge. Okay, so let's take a look. Let's talk about another reason why n equals 1 to infinity, of course, right? 4, -1 to the n times n, and then times x to the n. Okay, so how do you know you have one of these power series? You're going to have an x. You're going to have another variable. So obviously the directions will kind of give it away because it's going to say find the radius of convergence and the interval of convergence. But how do we know we have one? We've got this extra variable. Okay. All right, and this is kind of the cool thing. To find the radius of convergence or the interval, you always use the ratio test. Always. So we might not even write that. We'll see. For this, you always do the ratio test. All right, so find your paper, look up what was the ratio test. Okay, the ratio test is where you do the limit. You do a plus 1 over a sub n. I'm sorry, a sub n plus 1 over a sub n. Okay. All right, so we're going to do the limit as n approaches infinity. Now note, this is kind of important now because it's n, okay, not x. It's n. We've got a bunch of variables, so we have to make sure we kind of keep this all together. So we have 4, -1 to the n plus 1, and then times n plus 1, and then we've got x. X is going to stay, and then n plus 1. Okay, all over. We don't have a fraction, so that's kind of nice. All over, and then 4, -1 to the n, x to the n. Okay. All right, so we automatically do the ratio test. We're going to expand this, especially if it helps for sure. We've got 4. Remember, this is -1 to the n, and then times -1 to the first. This is this guy. All right, we've got n plus 1, and then same thing here. This is x to the n times x to the first. Okay, all over 4, -1 to the n, and then we've got n, and then we've got x to the n. Okay, so where's my red pen? Let's see what cancels here. 4's cancel, great. These cancel, great. My x to the n's cancel. Okay. All right, so what do we have? We've got the limit as n approaches infinity, absolute value. This is going to be -1, and then I've got n plus 1, and then I've got x. Okay, and on the bottom, I only have n. Okay. All right, if I take the absolute value, that guy goes away. So the limit as n approaches infinity of n plus 1 times x all over n. Now, I'm still going to take the limit of this guy. It has nothing to do with x. You can almost think of x as like a number, right? My limit is only dealing with n's. So I could do L'Hopital's rule just with the n's. I could divide everything by n, or my shortcut is, remember, if the exponents are the same, it's the lead coefficients. Okay. My x doesn't change because I'm not taking the limit on x. I'm taking the limit on n. Okay, so this goes to 1, and then x is still there. Okay, and actually, even though I took the absolute value, I still actually need the absolute value because I do have this x value. And we're not sure what that x value is. So I did take the absolute value on the -1, but I also have to take it on the x. All right, so this goes to 1, because that's my lead coefficient, and then x, and I have the absolute value. Okay, that's important because remember, x could actually be any number. So I need those absolute values up there to take into consideration that x could be negative. Let's write it like this. Okay, so now where does the ratio test come in? Besides, I performed it, but what does it mean down here, right? It says, as long as my answer is less than 1, it converges. So that means that this has to be less than 1. And that's when it's going to converge. Okay. Now, do we remember how to write this? This we would actually write as -1 because of the absolute values. Is less than x is less than 1. Okay. Okay, now this is where it just gets a little bit harder, because that's not too bad, right? I think we could do that. Oh, let's label, I got 7 of these. So this is problem 1. Okay, so the radius, I'm centered at 0, because this is like x minus 0, right? So I'm centered at 0. What's the distance from 0 to 1, and what's the distance from 0 to -1? See how that's the same? So my radius is 1. Okay, so box that off, that's my radius. Now, the interval convergence is from -1 to 1. Here's where it gets a little dicey. We got to know, should I put parentheses? Remember interval notation? Do I put parentheses or do I put brackets? And the only way to know for sure is you have to test them. Okay, so slide this up a little. So we need to take this, actually, can you see? Okay, we're going to take a look at this, n equals 1 to infinity for -1 to the n times n, and then I'm going to put in, I like to do the positive first, so I'm going to do a 1 first. So I'm going to let x equal 1. Okay, the problem is you got to test both of these. We know it's everything between -1 and 1. The question is what's happening right at -1 and what's happening right at 1. Unfortunately for those, you got to test them. But we know for sure that it is definitely any number between these two. Okay. All right, so let's, okay, so where were we? Okay, so we're plugging in a 1 for x, which this is kind of nice. It goes 1 to the n, right? So this guy we don't even care about. All right, so we've got summation of n equals 1 to infinity. Let's see, we've got this is an alternating series, and then this we don't care about because it's always going to be 1. And so we've got 4n. Okay. All right, so now we're going to do alternating series. Okay. What's happening with the alternating series? What was that test? We have to do 2 things. And I know it's an alternating. I mean, we could maybe do a ratio. If you want to do the ratio test, you could. A lot of these are pretty basic where the alternating series test works out really nice. So the alternating series test says, I just look at 4n. Okay. And then remember, each time n gets bigger, it's actually supposed to get smaller. So is that the case? When n is 1, I get 4. When n is 2, I get 8. It's not getting smaller, so this diverges. Okay. So if this diverges, then I make sure I did 1, so I do a parenthesis. I don't want to include the 1. Okay, then I have to do, how are we doing on space? Yeah, you can see that. Okay, then I have to test x equals -1. Okay, so now I do my summation, and I go back to the original problem. The original problem for -1 to the n, and then I'm putting in -1 to the n. So I'm going to fold this just so you can see what that original problem was. So I just put a -1 in for n. So we have to test, unfortunately, we have to test the endpoints. Okay. All right, so where were we at? Okay, so this is kind of nice. This guy right here, you can actually write this as, so I'm going to write 4n, okay, and then I'm going to actually do -1 to the n times -1 to the n. So I'm just going to rewrite it. Because this exponent is the same, you can actually multiply these two together. So I really have 4n, and I've got -1 times -1 to the n. Well, that gives me 1. So I'm really doing the summation of n equals 1 to infinity of 4n. Okay. We probably could figure this out that, hey, this is going, you know, if I just keep adding integers, I'm never going to converge to a number. But if I want to use the test for divergence, one of the very first ones we did, we said the limit as n goes to infinity on 4n. That is, it's just going to get bigger and bigger and bigger, so that's going to infinity. Let's see if I have it. The test for divergence just says what? If the limit does not exist, so that means if it's headed to infinity, or if it doesn't equal 0, then it diverges. Okay, so it doesn't exist, same thing as is headed to infinity. So this diverges as well. Okay, and so this is a parenthesis. Okay. Let's see. What else do I want to say? Oh, the reason we have to test the endpoints is because the endpoints will make it 1. The endpoints actually make it 1. And where's my paper? Here. If it actually equals 1, we can't make any conclusion. We don't know either way. So we're testing the endpoints because the endpoints are what actually makes it 1. Okay. All right. So where are we? Okay, so that was our radius. We knew our interval all along, but we didn't know what was happening right at the endpoints, and now we do. Yay. All right, let's try another one. We got 7. How are we doing in time? Okay, so the goal is 4 on A and then 3 on B. All right, here we go. Problem 2. Okay, summation n equals 1 to infinity. X to the n, that tells me I have a power series. That x to the n tells me I have a power series, 2n minus 1. Okay. All right. How do I test for, or I'm not even testing for convergence. I'm finding convergence. As soon as I have an x to the n, I know it converges. What do we use to find that? Ratio test. Okay. So we do the limit as n approaches infinity of the absolute value. Now this one does have a fraction, so it's gonna be a little long. X to the n plus 1 over 2 n plus 1 minus 1 all over x to the n over 2n minus 1. Okay. All right. And so what's the first thing we're going to do? We're going to change it instead of division. We're going to change it to multiplication. I think I can sneak it in here. Make sure you guys can see. The limit as n goes to infinity. We got a lot of variables, so make sure you're focusing in on the n. Absolute value, I'm going to change this to x to the n times x over, let's change this too. This would be what, 2n plus 2, but then you've got that minus 1. So it would be 2n plus 1. Okay. And then times the reciprocal 2n minus 1. So those don't actually cancel. Notice it's 2n plus 2, but then I got this minus 1 here. And then x to the n. Okay. So what cancels? My x to the n's cancel. And I think that's it, right? But, okay, let's take a look at what we have. We got the limit as n goes to infinity. Absolute value, I've got 2n minus 1, and then times x. And then I've got 2n plus 1. Okay. All right, so I am taking the limit on the n's. So if my exponents are the same, my shortcut is the limit is the ratio of the lead coefficients. Okay, so that is really, depending how we, let's see, how do we want to write this? So this is equal to, let's do it like this. Let's do the absolute value of, kind of the same thing again, isn't it? 1 and then x. Okay, because my, oh, I know what I was going to write. I was going to write 2 over 2. Okay, do we see that? I was going to write 2 over 2. Let me do that. 2 over 2 x. Okay, I like it like that better. Which is 1 though. Just, I don't know. Just as long as you guys see it, then you're in good shape. Okay, so now what does the ratio test say? The ratio test says that as long as this is less than 1, it converges. Okay. All right, and my center is, it's centered at whatever A is, and in this problem, A is 0. So it's centered at 0, and my, so this, actually, let's rewrite this. This is, how would we write this? Absolute value, we would write -1 is less than x, which is less than 1. Okay. So I'm going from -1 to 1. That's my interval. Okay, so what is my radius of convergence? My radius is 1. Okay, so my radius is 1. Okay. I know that if it's less than 1, it's automatically going to converge. So that's from -1 to 1. The problem is when x is 1, there's no conclusion. So we got to go back to the drawing board and we got to test each of these separately. All right, so let's try x equals 1. It's always nice to do the positive one first. So the summation, n equals 1 to infinity. Let's put in a 1 to the n. We're going to put in a 1 for x, 2n minus 1. Okay, we're running out of room, so let me sneak this up. Okay, so 1 to the n we don't really care about, right? So that is going to be, so we're really looking at this series, 2n minus 1. I think we're going to have to do the comparison test. Comparison test. Okay, so the comparison test says I need a benchmark. If nothing else, we'll get practice. I know it's a little tedious, but it's good practice to kind of see these tests over and over, so that's good. The comparison test, I'm just going to take this first group, 1 over 2n. Okay, this, or actually this guy. This guy is what? What is that guy? P-series, but specifically harmonic. Harmonic always diverges. Okay. So the comparison test says this have to, if this is diverges, this has to be true. Make sure you guys can see, yep. All right, so if it diverges, is this true? So this would be, you know, let's say I plug in a 4. This would be 1/8. This would be 1/7. Is 1/7 bigger than 1/8? Yeah, yes, right? Yes. I mean, if you don't know, you can divide it out or whatever. But yes, remember, as the denominator gets smaller, the overall fraction gets bigger. It's always opposite. Okay, so this is true. Where are we going with this? So this is true. Okay, so that means that when x is 1, it diverges, so we don't want to include it. We're only including things that converge. We're only including things that converge. All right, so now, slide it up. Just when we thought these problems were going to be short, they're still long. Okay, let's see. How is that? Can you still see some stuff? Let's, I think we're okay. All right, so now we've got to do when x is -1. So we do summation of n equals 1 to infinity. Go back to the original problem. It was negative. That was your x value. So I'm plugging this in for x. N over 2n minus 1. Okay, if you go back to the original problem, that was this guy. I have to plug in -1. Okay, so now what did I just create? I created an alternating series. So I'm going to do the alternating series test. Okay, lucky us. We get to do multiple tests here, right? Okay, and so remember it says don't worry about this. This identifies that it's alternating series, but just focus in on this. Okay, and it needs to be getting smaller. So if I plug in a 1, all right, if I plug in a 1, I get what? 1. If I plug in a 2, what do I get? 1 Um, if I plug in, what am I playing? 1/3, right? If I plug in a 3, I get 1/5. Okay, if I plug in, where am I at? A 4, I get 1/7. Okay, so that appears to be working. That's okay. All right, so now 2 says I want to take the limit as n goes to infinity of 1 over 2n minus 1. Okay. And what happens as the bottom gets bigger and bigger and bigger? It's headed towards 0. And what does that say? The alternating series test says if my things are getting smaller and the limit is 0, it converges. This converges. So what does that mean? I actually want to include -1. So all that work for those 2 little symbols. But the problem is at 1, my limit equals 1 for the ratio test, and so there's no conclusion. So I have to test my endpoints. Okay. All right, let's try. So then you go through, you plug in those endpoints, and then you test your series that you have. All right, let's see, how are we doing? Okay, let's take a look at this one. This is what, 3? I put this on, so I don't know if we use this or not. Does anyone know what 0 factorial is? 0 factorial is kind of by definition, we say that it equals 1. Okay, so just if we need that or we're evaluating, 0 factorial is equal to 1. All right, we got the summation, n equals 1 to infinity, x to the n plus 2 over 3 n factorial. The factorial only goes to the n. If I wanted it to go to the 3, I'd have to put it in parentheses. Okay. All right, so where are we at? Oh, how do we know it is a power series? We've got the x. The power series tells us we have an x. We're automatically going to do the ratio test. Okay. The limit as n approaches infinity. You're going to hear that in your sleep, aren't you? All right. The limit as n approaches infinity, absolute value of n plus 1, and then we have to do the plus 2, okay, over 3 to the n plus 1 factorial, okay, and then divided by x to the n plus 2 over 3n factorial. Okay, and what's the first thing we're going to do there? We're going to change it, the limit as n approaches infinity, the absolute value, we're going to change this as x to the n times x. Oh, no, actually, what are we going to, we want to change this to what? This is going to actually be, we can add these two together. Even though there's parentheses, we're just adding. There's nothing to multiply, so we don't have to have the parentheses. So this is really n plus 3. So it is going to be x to the n, but then it's going to be times 3. Okay, that looks better. Over 3 n plus 1 factorial. And then times 3 n factorial over, this one's okay, x to the n times x squared. All right, so what cancels? Grab my red. X to the n's cancel. 3's cancel. How do we cancel x to the third and x squared, right? 2 x's cancel. So I've got an x left over. And how do these guys cancel? Remember, this is like 5, 4, 3, 2, 1, 5 times 4 times 3 times 2 times 1. This then would actually be 6, but then times 5. So the 5's would cancel times 4, so the 4's would cancel times 3. You get the idea. So this, we can cancel these out, but leaving that first number, that biggest number still sticks around. Okay, so what do we have left? The limit as n approaches infinity. Absolute value, I think the only thing left on top is x, and the only thing left on the bottom is n plus 1. Okay, all right, so now remember, we're doing the limit as n approaches infinity. Okay, so what happens as n approaches infinity? What do we get? We get 0 times x, okay, which is really just 0, right? Maybe we'll leave the x in there. The ratio test says as long as the limit is less than 1, it's going to converge. Okay, so this is going to be less than 1. But because this is 0, tell me if x is 5, I'm going to do 5 times 0, which is going to be less than 1. If x is 10, it's going to be 10 times 0, which is 0, which is less than 1. No matter what x is, because this limit, because the n's had a limit of 0, this 1 over n plus 1, no matter what x is, it's going to converge, right? Because really the x goes away and we have this. And that holds true all the time. So we say that our radius is infinity, and our interval is from negative infinity to infinity. Those are kind of nice, right? So when the limit goes to 0, it's just going to, it doesn't matter what x is, and so it's going to converge all the time. All right. How are we doing on time? All right, let's do, let's see. This one's pretty similar. Let's do this one. Let's do 4. The summation n equals 1 to infinity. We've got negative 1 to the n squared, and then x to the n. That's telling me that I have a power series and then 2 to the n. All right, so we're going to go at the ratio test, right? Ratio test. Okay, so here we go. Let's do the limit as n approaches infinity. Absolute value. Okay, so negative 1 to the n plus 1, n plus 1 squared, and then x to the n plus 1, all over 2 to the n plus 1. And then we got to divide it by the original. Okay, a sub n. Oops, this is an n over 2 to the n. Okay. All right, so what do we have? We got the limit as n approaches infinity. Okay, so let's try to change this negative 1 to the n, negative 1. So we're splitting this up. We got n plus 1 squared, and then we'll split this up. X to the n times x, okay, over, we'll split this up, 2 to the n times 2. And then times, we're going to do the reciprocal of this guy, so 2 to the n. And then negative 1 to the n squared, and make sure I read this one right because this was hard to read. This should be x to the n. Okay. That's probably our longest one. Okay. How much cancels here? So this guy cancels. Does anything else cancel? This cancels. Okay. Oh, and x sub n cancels. Okay, so we got a few things. I think that's it. So the limit as n goes to infinity. Now, I still need the absolute values because x could be positive or negative. But this guy is going to go positive because of the absolute value. So this, I'm going to kind of at least take the absolute value of that. Because I'm multiplying, I can do that. So I have, what do I have? I've got this x, well, I've got n plus 1 squared. And I have the x. I think that's it on the top. And then on the bottom, I've got 2, and I've got n squared. Okay. All right. So, and again, this isn't too hard. We could multiply this out if we wanted to. We at least know that this is an n squared, but we could do n plus 1. You know, I think on the last assignment we had an n to the, or we had an n plus 1 to the 5th. But here we can multiply it out. N squared plus outer and inner would give us 2n, and then plus 1 times x over 2n squared. Okay. All right. So remember, we're taking the limit on the n's. The x really just doesn't have an impact. So we could do L'Hopital's rule. We could divide everything by n squared, or if the exponents are the same, it's the lead coefficients. Okay. So this is going to equal the absolute value of 1/2, and then we still have this x. Okay. And that is the ratio test says it's going to converge if that's less than 1. Okay, so it is, we should have written this. It should be -1 less than 1/2 x, which is less than 1. Okay, how do we solve this? Multiply everything by 2, even in here. Okay, and we get -2 is less than x, because these cancel, which is less than 2. Okay, so if I'm centered at 0, and then I'm going from -2 to 2, what's my radius? My radius is 2. Okay, my radius is 2. And my interval is from -2 to 2. Okay, now the only, oh, can we see? No, we cannot see. Goodness gracious. What happened? Okay, so I think, could we see all up to here? All right, so I said, okay, I said my interval is, or my radius, or my, I can't think of the word now. My center point, I'm centered at A, which is 0. So I'm centered at 0. And then my radius, and then I was going from -2 to 2. So my radius is 2. My interval, this is my interval from -2 to 2. I just don't know what's happening at -2 and 2. So I got to test those. Okay, maybe I'll do it. I'm going to actually go to the side. Oh, let's see. I might have actually put it here. Okay, so I'm going to actually take, can we see this? I think we can. I'm going to take the, I always like to do the positive first. I'm going to take the positive and put it in for x. So x equals 2. Summation n equals 1 to infinity, -1 to the n, and then this is going to stay n squared, and then this is going to be 2 to the n over, just happens to be 2 to the n. Who wrote this problem? All right, so that turns out nice, right? These cancel. Okay, so summation n equals 1 to infinity. I have an alternating series and then an n squared. Okay, so I'm going to do the alternating series test, which says I just have to focus in on n squared. All right. When I plug in 1, I get 1. When I plug in 2, I get 4. When I plug in 3, I get 9. Are they, remember, look it up, the alternating series, they have to be, the terms have to be getting smaller. Okay, so this does not work, so this fails. We could put this as what, I technically. So this fails, so this diverges. Okay, so what does that mean? We only want stuff that converge. Now just remember, if you do it this way, if I did x for, or I did +2 first. So +2 is the parenthesis. We did all that work for a parenthesis. All right, now what am I going to test now? I test the -2, summation n equals 1 to infinity, -1 to the n. Oh, I need this guy, right? I'm actually, I go all the way back to the original. N squared, and then I plug in a -2 to the n, all over 2 to the n. Okay, -2, I'm plugging in -2, so I do need those parentheses in for x. Okay. Okay, this, let's do some simplifying here. This turns out to be what? This is -1 to the n squared. This, I can actually write this as -1 to the n times 2 to the n. Or actually, I could even just multiply these two together right away. Let's do that. That might even be easier. I was going to kind of rearrange some things, but because these both have exponents of n, I can multiply these two right away. And so that gives me 2 to the n. And then I have n squared, and then I have over 2 to the n. Okay. All right, so we're in good shape. Those cancel. And so I'm looking at, make sure you guys can see this. I'm looking at the summation, n equals 1 to infinity of n squared. And I think we can kind of realize that, yeah, the numbers are just going to keep getting bigger and bigger. Technically, I'm adding them, but it's going to head to infinity. I could do, though, officially test for divergence, which says to go ahead and take the limit as n approaches infinity of n squared, and you can see that that's headed towards infinity. So really the limit doesn't exist, so it diverges. Okay. And so what does that mean? That means all that is telling me is I can come back here. This time I did -2 and put a parenthesis as opposed to a bracket. Okay, so this is my interval now. Okay. All right, let's stop there. That's going to be 40. And then we have to take it off centered at 0. So we're going to look at a few where we're centered off. Well, let's just, at this point, let's just keep going. All right, let's take a look at this guy. This is 5. Yep, this should be 5. Okay. The summation of n equals 0. Make sure, can you guys see this? Okay. N equals 0 to infinity, x minus 2 to the n over n squared plus 1. Okay. Actually, let's stop there. Let's stop. So we'll pick that up in B. It'll help just to maybe even take a little break anyways.